Hello everyone. The other day we created this Minecraft clone in Ruby on Rails, and I thought that this comment was actually an interesting topic for a follow-up video, which mentioned using Three.js to create a model viewer. And I thought, what if we create a service in Ruby on Rails where a user can upload a model? They can then create some like user-defined traits, maybe for like the color of the material that gets applied to the model, if there's any sheen or anything else. So right now, all this takes, if I edit one of these, is a color, which is just a hex code, if I zoom in a bit. But the other thing you can actually do with these, if I go back, is you can tell it to use a file. So this is from a .obj file. Of course, we're uploading objects. We're storing them in active storage, but the other thing that comes with OBJ files is the ability to upload custom materials. So here I have Blender. I've created this material here. I don't have it all hooked up, of course, but I created this custom material. It's this blue color. I then exported it as a OBJ file, which is the wavefront, if you can see that. And then I came over here and I uploaded it. And then instead of using the color I defined, which is this greenish color, it grabs the material from a separate file that we're also storing in active storage. So that's sort of the premise for this video. It's just a way to either have the user create custom attributes on the website or to upload the file itself. And you've seen stuff like this probably if you're like a 3D printing person. Maybe you've gone to like Cults 3D or Thingiverse. You've seen all of these models and stuff. And in this case, these are oftentimes just pictures or images or whatever. But you do also have like the ability to go to websites like free3d.com where you can get objects, and sometimes they include a material. And this is just a way to sort of upload both of those into a like object viewing service, if you will. And then of course they're all stored in active storage and displayable, etc., with all that other good stuff. So I thought it was a really interesting use case that we could maybe explore today. To get started, it's actually pretty simple. The overall project's not even that long. So we'll just go ahead, cd out of here. We'll do a Rails new, I'll hit F11. The only thing we need to do is call it video and pass in a -j of ES build, and then we can go ahead and run that. Now we are going to be using Three.js for this again, just like we did in the Minecraft tutorial. That was sort of the reason why we covered Three.js, because it does allow us to use a lot of other niche applications that we couldn't otherwise do if we didn't have a 3D viewer like Three.js. Now, of course, you could, in theory, build all of this from scratch. I'm sure that would be a fun exercise. But in some cases, it's better to just have a tool that does it for you. So what we're going to do is we're going to start by creating a scaffold. We'll call this scaffold, I think I called it displayables. And for the displayables, originally I only gave it a name, but then I also decided to give it a color, and these are going to be of type string by default. And you can include other options. If we come over to, and I have all these links in the video description, but if you come over to like Three.js and you look at the mesh standard material here, you can see there's a bunch of different options for what you can display on a mesh. And they even have a little thing here where you can check what each of these does. So if we like bring down the roughness, you can see it makes it shiny. You can bring up the metalness and it makes it metallic. And stuff like that. You can also turn on like flat shading if you're so inclined. And what you can do with this is if it's like a color, you just make it a string. If it's a number like this, you just make it a float and you clamp it between 0 and 1. If it's flat shading, it's a Boolean. And you just add those as extra variables here while you're creating your model. In my case, I'm only going to be doing the color, but we could of course add additional stuff for like the roughness and the metalness or like the flat shading. So what we might even do here is we'll just say flat shading is of type Boolean, just like that. And then we'll go ahead and we'll run this. So this will generate our scaffold for us. At this point, we can then do a Rails G active_storage :install command. I can never remember if it needs the G. Looks like it doesn't. So we'll just do active storage :install instead. And that should generate our migrations for us. So now we have our migrations and our scaffold. At this point, the only thing left to do is open up VS Code. And then we can start by just doing some basic setup in here. So I am using Ruby 3.2 for this. And part of the issue with 3.2 is I do still need to change this to use the proper version of the Foreman gem. So let me just do that real quick. So I'll say Foreman, and then I'll say GitHub : and then whatever the Foreman repo is. I can then run a bundle install command once that's done, and then I can go ahead and close the gem file. I'll have a link to this source code in the video description as well. The other thing we're going to need is to change our routes. So let's come over to our routes. Let's just make a route to the displayables controller and the index action. And then in our terminal, let's do a Rails G stimulus, and let's just call this the objects controller, I guess. So that'll just create our stimulus code, which allows us to use JavaScript in our web page in a bit cleaner of a way. Once we're done with that, we can go ahead and run a bin/dev. We can then come over to localhost port 3000. And when we do, we should hopefully get an error. If we close this, we can scroll down. It tells us to run our pending migrations. We can go ahead and click that. That'll run it for us, so we don't have to type Rails DB:migrate. Next, we can come into our app and our models and our displayables. And in our displayables, there's only a couple things we really need to do. We need to tell it, hey, you have a file, and eventually you're going to have a material. So we just tell it has one attached file and has one attached material. The other thing we want to do, of course, is if we have anything that needs to be in a specific format, maybe in the case of the color, we want to tell it that it has a validation, that it should be a valid hex code color. And of course, in my case, the way I did this was I just said, I left a comment here where I was like, color must be valid hex code. And then I just came down here, did a comma, and I hoped that GitHub Copilot would give me something. And then I added the message afterwards. So that's just where this came from. So again, the code will be in the video description. If you don't want to create this hex regex from scratch, you can also find it online. So once we have this done, we have now told the model it has these things. We need to come into the controller and tell it that it should allow those things as parameters. Because when the form submits the stuff, it needs to know, or the controller needs to know that the stuff the form is submitting is stuff that it expects and not something that a user is maliciously trying to include. So we add the file and the material here. If you're trying to do multiple files or multiple materials, instead of having the colon at the front, the colon goes after, and then you're just going to have an array. That's really the only thing that changes here. Maybe the name changes to files, but in our case, it's just one of each, so we leave it like that. Finally, we have to do the front end, which involves us going into our form, telling it that it has both a field for the material and a field for the file. So we'll come below the Boolean here and we'll just do both of those. So right here, we'll have a label for the file and a file underscore field, and then the same for the material. We then come into our underscore displayable, which is going to be our partial. And in our partial, all we really want to do is first tell it that it has a file and a material, just so it's a bit easier to see these. So we just call displayable.file and displayable.material, and this will work assuming we just want to see like that there's anything there. We won't actually be able to see the file or the material. It'll just be like the a random string of noise, but it's at least enough to know that we have those attached to our model. Speaking of which, we do want to make sure that we have the URL for the displayable.file. That'll be the local URL, which will be something like /rails/ blah, 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 nobody cares. And then we only assign that if the displayable file is attached. We do the same thing for the material. And at this point, we can connect our stimulus controller. So this is where our JavaScript comes in. We just put it down here beneath, well, I guess we can put it inside of this div, right? So right here, we just paste this in. And all this is just a content tag for a canvas. This creates like a regular HTML canvas with some data attributes in a Ruby friendly way. So we tell it it's a canvas with the controller set to the objects controller, which hopefully is what we called it over here. It looks like it is, objects. And then we have the file, we have the material, we have the color, and of course we also added in the flat shading this time. So let's go ahead and let's do flat shading is displayable.flat shading. We can go ahead and save that. And at this point, we can go over to JavaScript land and I can have a whole bunch of angry comments because I'm covering too much JavaScript again. Once we're in here, the first thing we want to do is import Three.js. But of course, we have to first include it. So to do that, we can stop our server. We can quickly run a yarn add 3 command. If you're using import maps, it's just going to be something like bin/import maps pin 3, I think is how you do it. And that'll work just as well, I believe. We can then go ahead and run our bin/dev again, come over here and refresh the page. Now to make sure that we're actually loaded here, we can do a console.log and say hello stimulus, refresh, and hopefully we get something in the console. If you don't, the quickest way to check if it's actually the stimulus controller or if it's the imports is to comment out the imports, because sometimes those cause these to silently fail. Now, if we come over here and we create a new object real quick, we'll just say this is our test object with a color of, I don't know, we'll do 123, 123. We can give it a flat shading. We'll click true for that, and then you can choose a file. Now you can either create a file in Blender, or you can go over to something like Free3D and just download a file if you're so inclined. The reason why I used this was because I actually had a GitHub repo that created some files in a, if I can find it, in a Python script. It then generated the files, and I wanted to view the files a bit more easily. And right here we have our output.obj file. But let's go over to blender.com if you'd like to create one of these from scratch. Go over to Blender, I guess, and search for it. I always forget what the actual, it's blender.org. Okay, go over to blender.org. Don't try to buy a Blender, try to download one. And then that'll give you an application. You can then go ahead and open it up. I'll just go ahead and close mine real quick so that we can do this from scratch. I'll come over here, I'll click quit, and don't save. So we can open up Blender, and we'll just very quickly do something pretty basic because I'm not really a Blender person. So I'm just gonna hit, I think, Shift A, or just A. Yeah, it's just A. Then it's gonna be like Shift X to delete. We can then click OK. That gets rid of everything. We can then do a Shift A to add a mesh, and this is gonna be a cube mesh. We can then come over here to the little wrench icon, add a modifier, do a subdivision surface, change the levels here to like 2, I guess, and then we can scroll in a bit. We can then do something like, I don't know, you can hit like tab. You can come over to one of these other options here. It really depends on how you want to do this. And then maybe just like click on your move tool and drag it up a bit so it's stretched. So we can like deform it a bit, maybe like that. So that gives us something, I don't know what. And then to do the actual shading, we can come over to the shading tab here. At the bottom here, we can click new. And then in here, we can just do some random combination of stuff so that we can at least see that we have something down here. So maybe we like turn down the roughness, and I don't know, we can come down here to the alpha maybe, or something. Just mess with it until you get something that looks interesting. Maybe for your normals, you just do some noise. And then for the noise, you like increase the roughness or something, or decrease it. And then you get something that looks, I don't know, interesting enough. And then at this point, we can go ahead and click File, go down to Export, export a wavefront.obj file. Put this somewhere where you can find it. In my case, I'll go to the Downloads folder, and I'll just call this my video_obj. I'll come over here, I'll click the object groups and the material groups, and then I'll click Export OBJ. Once we have that, we can then go ahead and minimize this, and we can come over to our video application again. I'll click on Choose File. I'll go to my Downloads directory. I'll look for the video_obj.obj file. Click Open. And then for the material, I'll choose the video_obj.mtl file. That's the material file. I'll click Open on that. I can now create the displayable, and we see we have 2 of these attached, and we now see Hello Stimulus appearing there. We'll then uncomment the Three.js, and it still appears in our console when we refresh, so we know that this is at least working. At this point, we can go ahead and finish up with the actual Three.js logic, which isn't terribly difficult. It's going to be pretty similar to what we did last time. First thing we want to do is make sure we can actually grab the elements in our data set. So we'll just do a this.element.dataset.object and .material, and that'll show us that we have our active storage URLs here. So that's pretty cool. That means we're actually accessing those. Now let's do the Three.js setup real quick. I'll hit F11. And for this, it's going to be pretty boring. It's essentially what we did with the Minecraft video. I'd recommend checking it out if you want to learn more. But basically, you create a scene, you then create a camera with an FOV, the size of the window as your aspect ratio, and then your near and far clipping, which is just how close you can get to an object before it disappears and how far away you have to be before it disappears. We then create a renderer, and this is where we do something a little different because we set the new 3WebGL renderer to be the canvas element inside of these braces, and we set the canvas to be this.element because remember, in our partial here, our content tag, we have the canvas as the element the controller is attached to. So when we call this.element in the stimulus controller, the element it's getting is the canvas itself. We then tell it the size should be just like half of whatever the window size is, so it doesn't take up the whole thing. And at this point, we can add a directional light. Now, if you want to see the sheen from like the roughness, you're probably going to want to make the light be like at least an intensity of 2, just so you can see something. And then at this point, you can go ahead and add the light to your scene by just calling this.scene add directional light. Now, because I'm lazy, I don't want to have to like move to the object every time or move away from the object whenever we refresh. So I just set the camera position to be you know, back a little bit and off to the side a little bit, and then I tell it to go up a little bit, just so you're at a interesting angle. Now we are going to create orbital controls for this, just like last time, which lets us pan around with our mouse, which just requires us to pass in the camera and the renderer element right here. Now the thing about this is our orbit controls has to be imported from the example projects, and there's actually a couple things we're going to have to import here. So I'll just paste these three in. The first ones are orbit controls from 3/examples/JSM/controls/orbit controls. You can find this on the Three.js GitHub repo if you're wondering like where these routes come from. It's just literally the path in their file directory. We then import the OBJ loader and the MTL loader. The OBJ loader is used to load the object, and the MTL loader is, you guessed it, used to load the materials. So that's how we do that part. We now have our controls. We have our camera set up. The last thing to do here is to once again create our animate loop. And in our animate loop, we just do the same thing we did last time, where we request an animation frame. We tell it to update the controls, and we tell it to update the renderer. We can go ahead and save this, come over here and refresh the page. And we now have a pretty boring blank canvas here. I'm actually going to move this over to the side so we get more screen space to work with here. But right now, there's really nothing to look at. So let's start by creating an object. We can do that above our animate loop. We just call create object. And then this is actually going to be a async function that we create down here. So for this, we're going to do something like that. We start by creating our object loader. We then need to check if we have a material file, which is just going to use a Boolean to see, do we have a material file? The way we check is by calling a new function called load materials, and we assign that to be this.material. So it's sort of the only way I could really get this to work. Now in load materials, which is a separate async function, what we do in here is we check if we have a element.dataset.material. And then actually what you could do is you could say if you don't have one of these, then just return would be probably a cleaner way of doing this. So you can use like a guard clause. And then after that, you can say, look, we have a material, so create a new material loader. For this material loader, what we want to do is create a promise, just like this. So we return a new promise with a resolve and reject, where we do a loader.load. Again, this is our material loader. We pass in a URL. If you're wondering how we constructed this, if you come over to, I think it's this page, which again, I'll have in the video description. It's the MTL loader for the Three.js docs. It tells you what all these properties are. So it takes in a URL, which is our dataset.material, which in our displayable is the material, the URL for the active storage file attachment material. It then takes in a function that happens if you load. So if we load the materials, so we get a .mtl file, then we just call materials.preload on it, and we resolve the promise. Then we have another one where we say, if we are in progress of loading the materials, we can do something else. And I'll show you how to use this in the create object function. So you can have like a progress bar if you want. And then if we get an error, we just do a reject. It's kind of pretty simple code there, but it's just something to make it work. So that's how we're loading the materials. So now let's say we get back to here. We've tried to load our materials. What happens if we don't have a material? If we don't have this.material at this point, what that means is we can set has material to false, and then we want to create a new material. So we'll say this.material equals await, and then we'll call this.material or create material from attributes. This is a slightly different function. This is going to be similar to what we did in the Minecraft video, where we create a material from scratch just using some attributes. So again, I'm going to paste this in because no one wants to watch me type. And we can just return a new 3.mesh standard material, which if you come over to the mesh standard material, that's what this thing is going to be, where we just pass in our hard-coded attributes. So for our color, we can just say this.element.dataset.color. We can set a roughness, which is going to be between 0 and 1 again, a metalness, an emissive, which is the thing that's going to make it like shine a bit of color. We can then, you could also change what color it's shining. In my case, I just set them both to be the this.element.dataset.color. We can then tell it the side, which is double-sided in this case. And then for flat shading, this was one where we added it in for the sake of this video, which is this Boolean right here for displayable.flat shading, which is inside of our flat shading. So what we can do is instead of doing true, we can just call this.element.dataset.flat shading like that. And that should hopefully work. And then wireframe, we just set to false because we don't want to see the vertices. We want to see the pretty little shape. So once we do that, we can come up to our create object again. So we've now created the material. Now, in the event that we did get a file and that file worked, we'll do an else here, which I know is gross. This is kind of just thrown together code. But what we'll do is we'll just say has MTL file is true, console log something, and then we call loader.setMaterials this.material. Because if we get the file loaded, it's going to give us back an array, which is in like a material creator object. And then we have to actually call loader, which is our object loader.setMaterials with this one. For the case where we create the material from scratch, we can just assign it in the function or the little method we're about to create. So down here, we can say loader.load. In here, we need to pass in our URL. So we get that from our dataset.object, which in our displayable partial is the object right here, which is the file, which is this URL for the displayable file. So that gives us our URL. Now the next thing to do is to create a little bit of logic for if we successfully load the file. So if the object is successfully loaded, then we check, do we have an MTL file? If we have an MTL file, the only thing we have to do is call this.scene.add and then add this object to the scene. If we didn't have an MTL file, we then need to traverse through each child in the object, check if it's a mesh. If it's a mesh, we need to tell it to use the material that we created from our color, our flat shading, and all that other stuff down here. So this is the thing we need to check. Once that's done, we can come down here and then we can do another this.scene.add afterwards. Now, if we want to create a progress bar, we can just pass it a XHR. And then in here, I'm just doing a console log, but then as long as it's loading the object, what it's going to do is it's just going to console log how far along it is. You can then hook that up to like a progress bar if you're so inclined. And finally, we can pass in a custom error function if we'd like, where we just say, look, an error happened, and then we can even do a console.error where we pass in the error, something like that. Now, assuming we've done all of this correctly, we can now refresh the page and we should get something that looks like this. It looks like a purplish color. Let's go back over to Blender. Here it's a bit pink. But we can now come over here, we can create a new file. We can call this, I don't know, like test, or let's call this without material. We'll pass this a color of, oh geez, I don't know. Let's just do something like, it's RGB, so let's do FF0000. So it's gonna be fully red. We'll set it to not use the flat shading. We'll choose a file, and for this, let's grab the video OBJ object again that we created, and we won't assign a material file. We'll just create the displayable. And now if we scroll in, we can see we have a rather ugly looking red egg here. Now, if we edit this, we can change this to use flat shading, click update, and you won't really notice a difference here. If we go back though, we can see we have both of these objects being rendered on the same page. The reason why that works is because in our displayable, we're giving each element in here its own controller and assigning this this.element to be the canvas that the controller is drawing to. So that's why we set all of this up in a nice little stimulus controller, because it's reusable and we can have multiple on the same page. But if we come in here to this material, which already has like the flat shading, the other thing we could maybe do is if we come down here to the red one, we can check in the object's controller here. We do have a roughness and a metalness. So let's see what happens if we set both of these to 0. You can refresh. Again, you're not really going to notice much of a difference, but hopefully right there we can get the reflection from the light depending on how it's hitting the object. So you can see sort of how these things work. But yeah, I just thought it was an interesting exercise to sort of take a look at how to create something like this. You'd of course want to add like more attributes being added in and make sure you're using like the correct shading and all of that to make sure that it's a bit closer to what the user's expecting. But I do think it's a really cool starting point for a rather interesting project. So yeah, hopefully this was interesting. Hopefully this was helpful, and hopefully I will see you in the next tutorial.